If you have one of these calculators, you'll see that there's only two types of log keys. We've got the common log, which is log, right at my thumb there, and the natural log. Now the common log is base 10, and the natural log is base e, 2.71828. Although common logs and natural logs are most frequently used, you may occasionally need to evaluate logarithms with different bases other than base 10 and base e. To do this, you can use the handy change of base formula. Now, if you have one of these calculators, this type of calculator allows you to change the base from e, which is the natural log, or 10, the common log, to 4 or 10 or 3.2 or whatever. So you might say, why am I learning this if I have one of these calculators? The reason is all knowledge is good knowledge. The change of base formula. Let a, b, and x be positive real numbers such that a is not 1 and b is not 1, but they can be any other positive numbers. Then log base a with argument x can be converted to one of these different forms. Log ax is log base b of x over log base b of a. Notice one log became two logs, and x went north and the base a went south. X was the argument, it remains the argument. A was the base, it became the argument, and we have a different base b. Now, if b were to be 10, the common log, we'd say log ax is log 10x over log 10a. And if the base we wanted to convert to was e, 2.71828, which is the natural log, we'd say log base ax is natural log of x over natural log of a. Let's break down this change of base formula. If I have log ax, one log becomes two logs when I change the base. Notice my base was a and my argument was x. Now, look at this x. It's up here. It looks like it's trying to go up, and certainly this a is down as a subscript. Clearly, it wants to go down, and I say, let them. Let the x go north, and let the base a go south, and we can create the new base. Now, this would be log base 10 if I didn't write anything, and I can choose whatever I want. Well, that's awful. I can choose whatever I want for the base. And that is the change of base formula. One log becomes two. Let's use the common log in a change of base. Log 425. Oh, sugar. I have this calculator. I can't just punch in log 425. However, I can change the base to the common log. Log 1025. 25 wants to go north. Let it. 4 wants to go south. Let it. Log 10, 4. Now, even on this little calculator, I do have the common log button, log, and this would get me approximately 1.39794 divided by 0.60206. And when I do that on my calculator, I get about 2.32. Now, what's the magic about this? What if we decided instead of going base 10, we said, no, let's go base e, which would be the natural log of 25. 25 wants to go north, let it. 4 clearly wants to go south, let it. And when we do this, we get this intermediary result of 3.21 divided by 1.38. When we simplify that, we get 2.32. Notice these two are the same. I'm not joking. You could have changed the base to e or changed the base to 10, and you're still going to get the same result. In this second example, I'm asked to do log base 2 of my argument is 12. On my calculator, I don't have a base 2 button, but I surely do have a base 10 button. So I could change the base and make this log base 10 of 12. It wants to go north, let it. 2 clearly wants to go south, let it. Log base 10 of 2. And when I do that and I put those into my calculator, I get 1.07918 divided by 0.30103. And that's approximately equal to 3.58. Now, if I do the same problem, and instead of going to base 10, if I say, well, 12 wants to go north, let it. 2 wants to go south. And instead of going base 10, I do base E, which is 2.71828. And I do natural log 12 over natural log 2. My intermediate result is different. It's 2.48491 divided by 0.69315. But when I crunch those numbers, this is approximately equal to 3.58. And again, you can see they're the same. I'm not kidding. You can change the base and make a statement of equivalency because they're equal.